Welcome back. Today I will show you how to use the Lndqst site from Lindab. It is a site where we can simulate the behavior of grills in a real situation. That is, we can simulate the space where we want to place the grills and see if the grills offer comfort or discomfort through the airflow and the noise they produce. We can also find information about grills that we want to use very quickly without doing a simulation. And let's see, here is the site. Okay, you can see here the address. Okay, let's see now. Let's see the informations about let's see some informations about some grills without doing a simulation first. Here on the calculate panel, click on the airborne products. Here at the product name, we want to select the name of the grill or the diffuser that we want. Let's say first that we want to use the RS15. This is a very common grill. It is used very often for offices, dining rooms, also halls. Okay, let's select it. Here is the duct connection size. Let's select this also. This you choose it by dimensioning the duct like I showed you. Okay, in the calculations lesson. So let's say we have 200 circular duct. Let's say you have a 200 circular duct. Okay, here check yes because we have plenum box. Okay, the connection is in the box. Here is the setup of the blades. Okay, let me show you first now the grill how it looks, the diffuser how it looks. Here is the diffuser. This is what we see in the ceiling. This is the plenum box. This is the duct connection where we connect the duct to the diffuser, and this here inside of the duct connection is the manual damper. It's the damper that regulates the airflow that is supplied or exhausted through the diffuser, because this diffuser can be used also for supply and exhaust. Okay, the blades here we were working setup inner rotation. The blades inner rotation is the setup of the blades here. This can be inner or outer rotation or vertical. It doesn't matter that much. Okay, this is the name of the diffuser with the plenum box. The MBB is the plenum box of the diffuser. Okay, let's select it. Here we have the air volume that we must enter it here. Now it's in liter per second. but I want to use cubic meters per hour. This depends on how you like to work. Let's place here the cubic meters per hour. Let's say we have 140. Then click calculate. And we can see here in the right part that we have the phase velocity of the air. This means that 2.1 meters per second is the speed of the air that is supplied through the diffuser. We want that the air that is supplied by the diffusers to be at around 2 meters per second. But don't go over 2.5 meters per second because it will be disturbing in the room. At around 2 meters per second it is okay. And then we have the total pressure loss. This is the air pressure loss in the diffuser. Okay, here we have 10 pascals. Okay, which is an okay value for this diffuser and this amount of air. Then we have the sound power level and sound pressure level. The difference between these two is that the sound power level is the sound that the air makes right when it exits the diffuser, and the sound pressure level is the sound that we perceive. Okay, because in most cases the supply diffuser is somewhere at around 3 meters in the ceiling, and the person who is hearing and the person in the room is at around 1.8 meters. So sound pressure level is the sound perceived by the person, by the individual in his field of work. I mean at around 1.8 meters. Or if he's standing on a chair, then this height is 1.6 meters and the sound pressure will be lower. Okay, so it's very important to have in mind this sound pressure level when we choose the equipments, because this is the sound level that we perceive. Then we have the flow, the air flow. It's 1.2 meters. This means that the draft of air supplied by the diffuser will be felt 1.2 meters from the diffuser. For example, if the false ceiling in which the diffuser is mounted is at 3 meters and the person inside the space it's at with it's at 1.8 meters, then it's okay. It won't derange the person, the individual. And here is a diagram where we see how the sound level grows when the pressure loss grows. Okay. Okay, now let's see another type of grill or diffuser. Another type that I use often is SD. Let me show it to you. This is how it looks. It's used for this type of grill is used for supply, and it must be mounted on a rectangular duct. And here we can see the frame. It can be single or double deflection. This means that single deflection is a single row of blades and double deflection is two rows of blades. Here is the technical sheet for this grill. Here you can see what single and double deflection means. This is single deflection. It's only a layer of blades. This is also a layer of blades, but they are reversed to this one. And these two are double deflection. You can see that there are two layers of blades. The double deflection grills are better to use because they can regulate the airflow better than the single deflection ones. Let's check here double deflection. Here is the grid, like I show you, horizontal or vertical. Okay, here is installation, how it's mounted. Let's say hidden screws because it looks better. Length and height, let's say, I don't know, 600 per 200. You have to look here in the we have to look here in the technical sheet of the grill to see the dimensions. We have here let's say 600 per 200, and this is the free area of this grill. It has 0.074 square meters of free space for the air to be supplied. Okay, color, okay, you can choose it as you like. Now let's enter the air volume. Let's say it's, I don't know, 200 cubic meters per hour. Click calculate. Okay, we can see the phase velocity here, I mean the airspeed, that is the air supplied by the grill. Total pressure loss, sound pressure level, which are very okay. We have an airflow of 3.4 meters, but the airspeed that is supplied by the grill is low. It's 0.8 meters per second, so it's very okay. You can You must do a correlation between these two, between the throw and the phase velocity. Okay. At low airspeed, you can have a higher throw. And like I said, it's used for high spaces. Okay, now let's do a simulation for the project that we are working on for a room in this project. I will click here. Let's click here on the indoor climate designer to go to the climate. Let's click here on the indoor climate designer to simulate our space, to do a real representation of our space and comfort that the diffusers you want to mount here. Okay, to see that the airflow is okay and to see how much space we need between the diffusers. So let's see, let's choose a space that we will work on here. Let's choose this director's office because it's the largest room in the project. So let's see the dimensions of the room first. It's 6 meters per 4.6. So let's create a room here. Let's create our room. Click on technical data, geometry. Here you will enter the geometry of the space. The length is 6 meters. The width is 4.6. And the height is, let's see, it's I need to look at the sections. Let's see here on the section, let's see the height of the room. This section is in the ground floor layout I provided to you in the resource tab. We want to take the height of from the floor to the false ceiling and the height from the floor to the concrete slab. So let's measure it. It's 3 meters. Okay, and height from floor to the false ceiling is 2.6. Let's enter these values in the program here. Height is 3 meters and the suspended ceiling height is 2.6. Okay, let's go back to the designer. Here we have our room. Then click on here on the switch to edit mode. On the supply terminals, let's see first our airflow for this room. We calculated this in the calculation lesson. I open the Excel file where I have my calculations. Here is the director's office at the floor tab, and we have 215 cubic meters per hour that we need to supply and exhaust. So let's go here. Let's think now how we want to place the diffusers. I want to place 2 diffusers for supply and 1 for exhaust. It would be best to place the supply in the extremities of the room and the exhaust in the center of the room, because this way the whole room will be ventilated. So I would like to place one supply grill here, one supply diffuser, and the other supply diffuser here, and exhaust diffuser in the middle. Okay, click here now on the supply terminals, right click, then find the diffuser. We have to see now what duct connection we need for the diffuser. So let's open the calculations Excel which I provided to you in the resources tab. Open this Excel file, and here we'll enter the airflow, but because we have 2 diffusers, we need to split the airflow by 2. So we have 215 airflow divided by 2 because we have 2 diffusers. So we have 108, let's say 110 per diffuser. So go here. So let's enter here 110 and see what duct we need. Let's say let's try 160. Let's try 100 and let's try this. This is okay. The airflow is pretty low because it's a pretty small room. When you will have bigger spaces, you will need diffusers with bigger duct connections. Let's use this 125 duct diameter circular duct. Enter here 125. The function is supply. It has plenum box. Here we'll enter the air volume per diffuser. Okay, and then click update search. And we have some diffusers here. Let's use the RS15, but you can use any type of grill that you want. Select it here, click the checkbox, and then go up and click add to project. Then add, and then close here. Okay. Click on Indoor Climate Designer. Okay, and we have our diffuser. Let's place. I want to place it here. Okay, we need to multiply it. We need to copy it because I said we need two of them. Right click on here on the diffuser at the supply terminals. Right click, clone to make a copy of it, one, because we want only one. And now we have two here at the supply terminals, two diffusers. And it's one on top of each other. Select it with drag and drop and place it where you want. In this case, we want it to be here. And now we will need a diffuser for exhaust. So click on extract terminals, right click, find diffuser, the function is extract, it has plenum box, you need to enter here the air volume, which is 210 because it's only one. I mean it's 250. It's 215 because we have only one diffuser. And click on update search. I'd like to use the RS15 because I want the diffusers to look the same in the same room. Okay, let's use this. The duct connection, you can see it here, is 160. Let's check here. 215, 1.16, 1.60 duct. The speed is okay. It is best to have the airspeed in the duct above 2 meters per second and below 5 meters per second. So let's use this RS15 diffuser. Let's add it to project. Let's click add first, and Indoor Climate Designer here at the room tab. let's place our diffuser in the center here. Okay, now I place the supply and exhaust diffusers. Let's see now the airspeed in the room, because this is why we made this simulation. So go to the room here, click on technical data. You can see here at the velocity tab that the airspeed is 0.12 meters per second. It is best to have in human occupied spaces airspeed of below um, 0.20. Okay, below 0.20 it's okay. So the airspeed is okay. We designed this ventilation very well. We chose the right diffusers, so we did a good job. In the next lesson we will continue with our project with the ground floor. You can also see here the sound pressure level. It's 24. This is the result here, the result column. Okay, and this is the required column. The required was a maximum of 30. Here at the designer tab, you can click here on the sound view to see colorful representation of the sound power values in our space. With green it's below 27, which means that is good. You wouldn't want this to be with red. You can save your simulation by creating a free account on this site and save it here to use it later or check it on another time, or you can print it. You can generate a room report.